Hello, Professor. Here is my Milestone 2 algebra lesson plan. I am conducting it on linear equations. I have filled the following information here, and I will now continue on with my lesson. These here are my guided notes. To start off, I am covering the linear equations. What is a variable? A variable is a letter that represents an unknown number. For example, it could be such as x, a, or n. And this equation here, my variable is the letter x. X plus 4 equals 7. X here is representing an unknown number. The variable x can take any value in an equation. Example 1. What is my variable in this equation? 2x plus 6. I know that a variable represents an unknown number. Therefore, my variable in this equation is the letter x. X is a variable and can take any value. Example number 2. Plug in x equals 1 into 2x plus 6. If I was to plug in the variable x, which we know is the number 1, I would do 2 times 1 plus 6. Then I would go ahead and solve my equation. 2 times 1 we know is 2 plus 6. 2 plus 6 equals 8. Therefore, my answer is 8. What is a linear equation? A linear equation in a one variable where x is the variable and a and b are coefficients. A linear equation can have more than one variable. A linear equation is an equation in which the highest power of the variable is always 1. It is also known as a one-degree equation. How to solve linear equations with one variable. I will start by simplifying the expressions inside the parentheses, brackets, braces, and fraction bars. Then, step number 2, the same quantity can be added, subtracted, multiplied, or divided from both sides of an equation without changing the equality. Any terms of an equation may be taken from one side to the other with a change in its sign. This process is called transposition. Now I will demonstrate how to solve linear equations with one variable. The goal here is to calculate the value of x. X has a value that we currently do not know. We want to get x, the variable, by itself on one side of the equal signs. Now, whatever you are going to do to one side, you have to do to the other. To isolate the variable x, we have to get it by itself. To start, we will subtract by 4, but whatever you do to one side, you have to do to the other. Therefore, I'm going to subtract 4 from 7 as well. I get x, which is now isolated, and 7 minus 4 we have to solve. 7 minus 4 is 3. Therefore, I now know that x equals 3. Now, if I wanted, I could also double check my work and plug the x back into the problem. If I plugged x back in, I would do 3 plus 4 equals 7. 3 plus 4 does in fact equal 7. 7 is equal to 7, so we know that our problem is correct. Example number 2, solve x plus 9 equals 15. Once again, I need to isolate the x variable, so I will subtract 9. Now I know once again that whatever I do to one side, I have to do to the other. I have now isolated the x variable. 9 minus 15, or 15 minus 9. We know is 6. Now once again, I can go ahead and plug my answer back into x. Now if I plugged it in, I would do 6 plus 9 equals 15. 6 plus 9 does in fact equal 15. 15 and 15 are both equal to one another, so we know that our answer is correct. Here are more examples on how to solve linear equations with one variable. Once again, I need to isolate the x by itself. Now this one is a subtraction. To isolate the x by itself, I am going to have to add 3, since this is a negative. Whatever I do to one side, I have to do to the other. My x is now isolated. 9 plus 3 is 12. My answer is x equals 12. I'm now going to go ahead and check it by plugging it in. I will do 12 minus 3 is equal to 9. 12 minus 3 is in fact 9. 9 is equal to 9, therefore I know that my answer is correct. Here I have a different kind of a variable. This time my variable is not x, but it is a different letter. Oftentimes you will see variables that are different letters. In this problem we have n minus 8 equals 7. To isolate the variable n, I am going to have to add 8. Whatever I do to one side, I have to do to the other. N equals 7 plus 8 is 15. I'm going to go back and check my work. 15 minus 8 equals 7. 15 minus 8 is in fact 7. Therefore, I know that my answer is correct. Now here I have a different one. This one is multiplication. So the opposite of multiplication I know is division. Therefore, to get my variable by itself, I am now going to go ahead and divide. To get the x by itself, I divide by the same number. I'm going to divide it by 3. Whatever I do to one side, I have to do to the other. And I now get x equals, now I have to figure out what 12 divided by 3 is. We know that that is 4, because 3 times 4 equals 12. My answer here is 4. Now this problem I can also go ahead and check by plugging in my x. For this one, I will do 3 times 4 is equal to 12. 3 times 4 does in fact equal 12. Therefore, I know that my answer is correct. Here is another one where we have to divide because this here is multiplying. To divide it, I need to divide by the number that is next to the variable. Therefore, I'm going to be dividing by 7. Now, whatever I do to one side, I have to do to the other. My x is isolated, and 14 divided by 7 is 7. Now I can double check it by plugging in my x. Oh, I messed up there. 14 divided by 7 is 2, not 7. If I plug that back in, I can do 7 times 2 is equal to 14. We know that is correct. Now here I am going to solve linear equations with a variable on both sides. When a variable is on both sides, that means when there are on both sides of the equal sign. This means that it has to be rewritten so that the variable is only on one side of the equation. My steps to solve this are: number 1, use the distributive property to remove the parentheses. Number 2, combine like terms on the same side of the equal sign. Number 3, use the addition property to get the variable on one side of the equal sign and all terms that do not contain the variable on the other side. Number 4, use the multiplication property to isolate the variable. And number 5, check the solution by plugging in your results into the original equation. Now here is my section of the guided notes, which I would then go ahead and explain. I want to get the variable on one side of the equal sign. Therefore, I want to bring my x over here. To do that, I will have to do the opposite to get it on the other side. Therefore, I'm going to subtract x on this side, but I also have to do it on the other side because we know that whatever you do to one side, you have to do to the other. Now over here, x, subtract that, I get 2x plus 4 is equal to 12. Now I want to isolate this 2x here. To isolate that, I'm going to do the opposite of what this says to bring this positive 4 over. Therefore, I know that I have to subtract 4. Whatever I do to one side, I have to do to the other. 2x equals 12, 11, 10, 9, 8. Now, once again, I here have to isolate my x. This right now is multiplying. I have to do the opposite, which I am now going to divide by 2. Whatever I do to one side, I do to the other. Now I know x is equal to 4 because 8 divided by 2 is equal to 4. Now in this problem, I can also go ahead and check my work by plugging it in. If I was to plug in my value for x, my problem would look something like this. 3 times 4, because we know that x is equal to 4, plus 4 equals 4 plus 12. Okay. 3 times 4 is 12, plus 4 is equal to 4 plus 12. Here we can see that these two are the same. Therefore, we know that our answer is correct. Now on example number 2, I will do the same to be able to find out what my value for x is. I will subtract my x to be able to bring it on one side. I am going to subtract 2x. Whatever I do to one side, I have to do to the other. 4 minus 2 is 2x plus 3 equals to 15. I want to bring my numbers without the variable x on the other side, so I will subtract 3 from both sides. And I will get 2x equals 12. The number next to the variable right now is multiplying. To get it by itself, I am going to have to divide by 2. Whatever I do to one side, I do to the other, and I receive x equals 6. Once again, you want to go ahead and plug in your variable into your equation to see if your answer is correct.